Good evening, Saintsmen. We're going to go live right now with the live stream for this next upcoming assignment that we guys had in class today. If you guys have questions in the chat as we're going, this is actually a great opportunity to ask them because hopefully you're following along with some of these problems that we had. I want to show you guys a feature. We haven't really gone over it, but this isn't just me being decorative. This is functional right here. Click here for textbook, or you click on the textbook. If you guys do so, you guys can access actually a free copy of the textbook. Now you have to make sure that you choose Bridge to Success 2019 and then click on our geometry textbook. But then we can find even here in chapter 2, and we go right here to where is it at? Page 118, I think was that first. Sorry, 119 being that first problem that we had, which was number 17. So let's go ahead and take a look at that guy. On number 17, we use a proof to make our point here. All right. So as we start with our two column proofs, on the left we have statements. On the right we have reasons, and then now we've kind of just kind of broken the glass here, kind of broken the dam to get some ideas flowing, because we now know we're going to copy this verbatim as our first statement. Okay. Which is that angle 2 is congruent to angle 3. Also, that TV bisects UTW. And this is, of course, the given. Now remember what's going to go here on the right-hand side over here. We're going to have definitions, properties, postulates, and theorems. All right. If it's not those things, we can't write it on this side. All right. Let's go ahead and erase that stuff so we have room. Just a reminder of the only things that can go on the right side. It's very to the point, it's succinct. So here we go. Number 2. Now, what else can we conclude based upon the given statement? That's what goes through my mind when I go ahead and try to solve these problems. So it's this that jumps out at me, that TV is a bisector for UTW. So this is UTW right here, which means that this angle and this angle, angles 1 and 2, have to be congruent. Because TV, right, bisects and makes two equal parts. So this is the definition of the angle bisector, okay? You can even just put the definition of bisector. Some of you guys will even just write bisector, and I already know that it's a definition, okay? So here's what our last statement has to be. It has to be angle 1 is congruent to angle 3. Now, we know that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3. Therefore, angle 1 would have to be congruent to angle 3 through the, now we have two options here. This is the transitive property, right? If A equals B and B equals C, then A equals C, right? We have 3 subjects and 3 statements, each used twice. Now, here's the other thing you guys could get away with in this problem in particular, okay? If you told me this was substitution, I would actually accept an answer. Because here's why. Remember what substitution is. It's a replacement. It's a direct swap. Okay, sorry, that's really butchered because my pen is really smudgy over here. I'm trying to write off of my screen. Okay, it's a little bit better. It's this. Since we have 2 and 3, I'm going to take 2 and swap it for angle 3. It's a direct replacement, therefore substitution. Excuse me, I would accept that answer too. All right, next problem. We had, let me look this thing up here. We had page 118, number 26. So go ahead and snip that. Okay. It says use any format, and we're not doing that. We have, of course, only one format that we use in this class. It is the 2-column proof. So the left side is our statements. Right side is the reasons. All right. 1 and 1. So we have angle 3, and we have to copy this directly and exactly. So angle 3 and angle 2. I'm going to abbreviate and. That's okay. And if you even abbreviated complementary, it wouldn't hurt my feelings. And then we have the measure of angle 1 plus the measure of angle 2 is equal to 90. Now, we had this happen in class where you guys are asking about this whole idea of measurement. Is that the same as if we just say angle 1? And I accept it. It's just saying that if we measure it and we give it a numerical value, it's the same versus when we have this angle 1 by itself, we don't have a numerical value assigned to it, okay? So, as we know to start, this is our given. Number 2. Now, we have this statement. Now, what can we conclude from our given? Remember, that's what I told you guys in that last exercise that we did. Take a look. How do we start? Well, let's take a look at the given and see what else can we conclude. Well, if angle 3 and angle 2 are complementary, that means that angle 3 plus angle 2 is going to be equal to 90, right? And this is just the definition of complementary angles. Now, this is going to seem very mechanical because it has to do with structure, mathematical and algebraic structure. Because now, and we could even say this is actually maybe make a little more sense as if we call it the measure of angle 3 and measure of angle 2. That's fine. Okay, same. Now, what we can say is that since these things both equal 90, wouldn't they equal each other? So couldn't I say that the measure of angle 1, or I'm sorry, measure of angle 3 plus the measure of angle 2 is equal to, and I'm going to show you guys something in a minute here, is equal to the measure of angle 1 plus the measure of angle 2, right? This guy and this guy are going to be equal to each other. And why? Well, just like in the last problem, we're going to employ the transitive property. Now, since we have those guys equal to each other, let's get rid of this and this, right? Well, could we do to both sides as we have that angle 3 is congruent then, right? We can use congruent notation and not equality and drop off measure and say angle 3 and angle 1 are congruent. And this is through because we just lobbed it off and we subtracted it from both sides. Now, I'm going to show you guys something real quick on this problem, okay? Here's the alternate universe that you could have operated in. Let's go back to this step right here, okay? So what if this had happened? What if we had set this up and we had said the measure, right? We had put this step first, right? The measure of angle 1 plus the measure of angle 2 was equal to the measure of angle 3 plus the measure of angle 2. And then we do subtraction, right? What would we be left with? We'd have the measure of angle 1, or angle 1, congruent to angle 3. Now, here's the issue. This would, of course, be subtraction. Now, in order to solve your proof to be done, this proof step needs to be identical, and it's not. We need to flip this guy around. We'd have to say the measure of angle 3, or angle 3 is congruent to angle 1. Flip-flop. And we gotta look up which property that's going to be. Wonder if anybody wants to chime in the chat and let me know what you think. But we just dealt with this, okay? You could do, this would be symmetric, okay? So, next. Where's it at? Here we go. Page 103. Back here. Where's 103? Oop, not there. 103. Cool. And I'm looking for number 14. Ooh, here you are, number 14. Let's go ahead and get the snipping tool. All right. So, starting again. Many of you guys got to this in class today, and we got a little stuck on this one. Okay? So we have the statements and we have the reasons. And I think that little strategy I just gave you guys in terms of something you need to internalize. First, of course, recopy this, right? These statements that are at the top. AB congruent to FG, and BF bisects, and it's a line, right? AC and DG, okay? And this was given. So, what do we say next? Well, what else can we conclude from the diagram and from the given? And it's this. If AC is bisected, right? So let's go ahead and look at our given. What other conclusions we can make? Well, here's one I can make. I know that AB is congruent to BC. Moreover, I know DF is congruent to FG. I see somebody in the chat had chimed in about symmetric, but it was a little late for me. And that's okay. Let's see if you guys can chime in. I'll give you guys another question. Let's see if you can chime in. Give a shout out to whoever can chime in there. So AB, BC, congruent, DF and FG are congruent. Why? It's because of this. What was established back at the given, this is the definition of bisector. In this case, it's a segment bisector, not an angle bisector like we dealt with before, okay? And you can feel free to mark your diagrams, especially on your test. I know you have loaner textbooks. I find you guys marking those all the time, and then the guys, by the end of the day, find all these pencil marks. I have to mind when you guys do it, but please erase those, okay? Hasn't become a crazy problem yet, but I'll, I can address that later. So, AB congruent to FG, and we're trying to get that BC is congruent to DF, okay? Now, AB is the same as BC, right? So we could say that BC is congruent to FG through substitution, right? We just swapped out BC for AB because of this, right? And this was given. And then number 4, we have FG congruent to BC, okay? So with BC as the first statement, now can we swap out FG and DF? Yeah, we can, because they're congruent. So we can now say BC is congruent to DF, also through substitution. I would like for you guys to do the 2 substitutions rather than trying to employ the transitive property. I think some of you guys took that route and did this in 3 steps and just jammed in transitive, right? Because you swapped out simultaneously AB for BC and DF for FG. AB is congruent to FG, right? And if AB is congruent to BC and DF is congruent to FG, given that AB is congruent to FG, it's just 1 step too many for me. So yeah, we can just actually go right to here and we're done, okay? So, got 3 proofs now. We got a question about, do we not need to convert congruence to equality, and that's correct. We're going to use those 2 interchangeably. It's just, again, after teaching this course for so many years, it just isn't worth the squeeze, okay? I think you guys then abuse and don't really properly understand the definition of congruence. Okay, last but not least, got page 113. Let's see if we can find that guy. Page 113 and number 21. Oh. All right. Well, there's a couple methods we could use for this one. Okay. So, again, statements. Left, reasons. On the right. I had people going S and R. Don't do that. I won't give you credit. It won't conflict or inflict. It won't inflict bodily harm if you guys actually write the whole word statements. Okay. So a lot of shortcuts with these 2 column proofs I actually encourage. So you guys just don't know. So I know that's kind of a trust me, bro, sort of reasoning, but just what it is. You have to do it, whether you like it or not. QRS and PSR are supplementary. Look, I'm not even gonna write the whole word supplementary. We're gonna abbreviate. You're welcome. And that is given. Jeez, my pen is really struggling here. Okay, which means that angle QRS plus angle PSR. Oops. Equal 180, which is definition of supplementary angles. How did I just go there? Well, guys, remember what I told you. As soon as we start, just go back to the given. Go back to the given. What else can we conclude? How is that going to help us? Well, let's talk it out. Let's use the dialectic here, okay? Though I'm chatting with myself, I suppose. Not much of a dialectic. So QRS, it's QRS and PS R Q, one second, QRS and PSR. So these guys are supplementary. So it's this angle and this angle right here. Okay. So this is the question. What do we got going on right here? All right. And we want to know that QRL and PSR are going to be congruent. So this is going to be an angle of interest. This angle, and this angle. 1, 2, and 3. Now, I can't now call them that. I can't just give names to stuff. I can't just like rename you in class, right? I can't just call it, decide, if your name is Juan, that you're really going to go by Billy. This is improper. But for now, just to, see what we're associating, it's going to be, these are the 3 angles of interest. Well, how can I relate this angle to this angle? Well, I don't know yet. They're going to be congruent. But how am I going to prove that? Well, I know these guys have a relationship, which is that angle QRS and angle QRL are supplementary. And I know that for a fact because they are a linear pair. Therefore, QRS plus QRL equals 180. And that's definition supplementary. Now, I actually never needed to take this step. I'm going to show you guys how to shortcut this one in just a moment. So then we can then conclude that QRS, right, and PSR and QRS and QRL both equal to 180. Are going to be equal to each other. And this is transitive. And then, of course, we'd have angle QRL is going to be congruent to angle PSR through subtraction. Now, so here we go, guys. Here's how we're going to shortcut the whole thing. Okay? Let's go back. We have this. I'm going to show you guys the alternate universe where we could have been more elegant mathematically. We have statements, reasons. I don't know. Oh, geez. I need to erase all that stuff. Okay, it's back. How do I snip you? Where is it? This is a new thing for me. No, not snip. I want to highlight this stuff right here. How do I do it in this game? I know how to do it in crop. Okay, I get to rewrite. That sucks. Okay, angle QRS and PSR. And you guys, if you want to write this, it's fine. Supplementary. That's given. Now, I'm going to use this guy right here. Angle QRS and angle QRL are also supplementary because of the linear pair. And now, here's what I know. You guys remember we have a theorem we can use here. It's going to make this short because we already did this whole proof. We don't have to relive this every single darn time. So it's going to be that we have angle QRL is congruent to angle PSR because of the congruent supplements there. Remember, we have 2 angles. Let's remember what that states, right? By the way, this is why you guys will get on board with this stuff, because everybody wants to do less work, okay? Can't get my typing tool to work. It's 2 angles that are supplementary to the same angle are congruent. Okay, that's what our theorem was. It's in your notes, okay? That's why it's great. Look at that. Who doesn't want to do less work? 3 steps versus 6 steps, okay? And there you go, guys. I'll see you guys in class. Office hours are open tomorrow. Good luck.